More with quadratics in vertex form. Graphing quadratic functions. In order to graph quadratic functions that have more than one transformation in them, we need to consider what does the transformation mean. So the first thing we're going to do here is look at each equation and decide what does each part mean. And we look at it from left to right. The 2 is our vertical stretch factor. And it's telling us we have a vertical expansion by a factor of 2. The plus 3 is in the brackets with the x, and it's indicating horizontal movement. Remember that we usually write x minus the value, so this is like writing x minus negative 3 squared, which means we're doing a horizontal shift left 3. And finally, the minus 4, it's tagged onto the end. It's affecting the y values, and it's telling us that we have a vertical shift down 4, because when we subtract, things are getting smaller. The next equation, f at x is negative, means it's a reflection in the x-axis. And this x minus 2, again, it's really x minus positive 2, which tells us we have a horizontal shift to the right 2 units. F at x is a half of x plus 1 squared plus 5. 1/2 is between 0 and 1, and therefore it is a vertical compression by a factor of a half because it's going to flatten the curve. And again, this is positive, but it's like writing subtract negative 1, so it's a horizontal shift left 1. The plus 5 tells you add 5 to all of those y values you already had, so it's indicative of a vertical shift up 5 units. F at x is negative 4x. That negative 4 tells us 2 different transformations. First, it tells us a reflection in the x-axis because of the negative, and then it tells us a vertical expansion by a factor of 4 because 4 is bigger than 1. The negative 10 is after I've squared it all and multiplied by negative 4, so it's tagged onto the end and it's affecting y values, so everything shifts down 10 units. You'll notice I'm very particular about the wording I use for my descriptions, and that's the type of wording that I expect to see on your unit test next week. I always want to see vertical or horizontal when it comes to a shift or an expansion, because although we don't teach horizontal expansions in this course, we will do them if you continue with your math studies. Negative 7 indicates reflection in the x-axis and again a vertical expansion by a factor of 7. You'll notice I'm always doing my descriptions from left to right. Plus 2 in the brackets with the x. It's attached to x. It's telling you shift left 2 units, and you need the word horizontal. And the last one, the a value, is just a 1. So that tells you there's no reflection and no stretch. We simply have a horizontal shift to the right 1 unit and a vertical shift up 2 units. How does all of that help us? It's going to help us graph quadratic functions when there are multiple transformations. So the first thing I would suggest you do is graph the base graph or parent graph. F at x is x squared equals x squared. Just like you do with sports, you always stretch and reflect first. So you're going to sketch f at x is ax squared. In order to do that, we already discovered that we multiply the y values by the a value and plot the new point. Okay? Then we do our vertical and horizontal translations. So that means we're going to take the graph of f at x is ax squared, and we're going to move it left and right, up and down the appropriate number of units. What does that look like when I graph it? Well, first we're going to look to describe in words the sequential steps. So that really means what are the steps in order. So we might want to write that on our page, that we're really looking for what we're going to do in order to graph the function. We also want to graph it without a table of values. That's really important. And then we need to state the vertex domain, range, axis of symmetry, whether or not there's a maximum or a minimum, and what that value is. So the first thing I need to look at, again, I go back to my equation and I start left to right. I have a vertical expansion by a factor of 2. That tells me multiply the y values of f at x is x squared by 2. And that's my first step. This plus 3 means take that graph, f at x is 2x squared, and sorry for the interruption. We're going to take the graph of f at x is 2x squared, and we're going to move all the points left 3 and down 4. And we can do that all in one step. Okay. To graph the function, we're going to do that right now. So let's take a look. We have a few steps we can do. We could complete a table of values where we do our x squared, and the x values get multiplied by 2, or sorry, not the x values, the values of x squared, which is f at x, the y values are getting multiplied by 2. But that's a lot of work, and I don't recommend doing that. I always start with my base graph, so 0, 0, 1, 1, 2, 4. The key points that we talked about in video lesson 6, I believe, are what I would start with. And of course, I can't draw good lines with my Mobi. It's not very good for doing that, or I'm not very talented with it yet. Now, the next thing I do is I'm going to pick up another color. I have my vertical expansion by a factor of 2, and that was multiply my y values by 2. So the point 0, 0 is invariant so far. 1, 1 becomes 1, 2. 2, 4 becomes 2 and 8. Negative 1, 2 becomes negative 1 and 2. Sorry, negative 1, 1 becomes negative 1, 2. And negative 2, 4 becomes negative 2, 8. And I'm going to try and draw this one a little better, but I'm not having a lot more luck. And that ends up being f at x is 2x squared. So the last thing I have to do, and of course the table of values gets a little confusing for this, so I try and avoid doing it. But the last thing I need to do is, well, I was hoping to change the color, move everything left 3 and down 4. But I'm going to use the last graph, the one that I've drawn in black, to do it. So I took my vertex and I moved it left 3 down 4. And I took this point and I went left 1, 2, 3 and down 4. And I'm going to take this point left 3 and down 4. And this one left 3 and down 4. And left 3 and down 4. I didn't count right apparently right here. Let's try that again. Oh no! Let's see if Control Z works. It's working. Oh, good. All right, I need to make my eraser a little smaller there. Apparently I didn't count right. 1, 2, 3 and down 4. There, that's better. And this last point, left 3 and down 4. And again, I'm going to draw my graph. And of course, when you're drawing these on your test, you're going to have all these lovely U-shaped curves that look much better than what I'm drawing on the screen right now. Because of course, the device I'm using is not overly user-friendly sometimes. Okay, now, what can we read off of there? We can read our vertex. Our vertex is pretty straightforward. It's at the point negative 3, negative 4. Well, that's interesting because that tells me my vertex was at negative 3, negative 4. I could have got that from the equation in vertex form. If I look up here, that told me go left 3 and down 4, and that's exactly what my vertex is. The equation of my axis of symmetry is x equals negative 3 because, of course, I always take the x coordinate of my vertex because it's a vertical line through the vertex. The minimum value is negative 4, and again, I can get that right here from the equation. The domain, nothing changes for the domain of a quadratic. It's always an element of the real numbers. And the range, that part is going to change. It's opening up, so it's greater than or equal to, but my vertex dropped to a y value of negative 4, so my range will be at y is greater than or equal to negative 4, and then an element of the real numbers. And just to practice, page 15, exercise 8, number 3. Good luck.